architectural Nexus. We're currently in our Sacramento, California location, which is a certified living building. So we're currently standing in our lobby area, which you can see has a large green wall as its main focal point. We actually utilize this wall as a path for our gray water system. So we make a little bit too much gray water for our toilets to use for flushing, so we utilize this living wall as an excess path for that. This wall waters 3 times a day for 2 minutes, just using a drip irrigation through the top. And it's planted into a felt plant media, which allows the water to percolate down, and as long as that felt media stays moist, the plants will survive. You can see that some of the plant species are either a little bit smaller than some, or a little bit bigger than some, or some might be, kind of looking like they're not doing too great. We actually have turned this wall into kind of a science experiment. We take different kinds of plant species and plant them into the wall to see which ones will survive better utilizing gray water. So we can make a comprehensive list of which plants would, thrive in that kind of environment. Since gray water is a little bit salty, we add things like an organic salt buster and a little bit of fertilizer to the wall to kind of help those plants survive. You can see that there's grow lights on the top. These are LED. And we utilize these at nighttime. So we turn them on for 4 hours starting at 5 p.m. They run for 4 hours, then they'll turn off to give the plants that dark period that they need. They'll turn back on at 4 a.m. and they'll be on from 4 a.m. to 8 a.m. This kind of helps simulate the daylight that the plants need and the sun that they need. Since we weren't able to utilize anything like skylights, we do have a few, floor-to-ceiling windows that the plants get some light through, but the majority of the light is fed by these LED lights. So now I'm going to take you into our open office area where we'll talk about some other strategies. So this is our open office area. As you can see, there's no artificial lighting on in this space at all right now. It's all being daylit by our operable windows, which line the whole perimeter of our building, as well as a solitube product that we have up on our roof. The solitubes take the light from the little dome on top of the roof and they refract it down into the space. And this is what our building looks like the majority of the time. We only have the lighting on, in the winter time when it starts to get dark a little earlier. That's really the only time we have the lighting on. The other thing we have in this space, and we have it on both sides of our open office areas, is this little light right here on the wall. When that light turns on, it tells the occupants that the temperature and humidity are optimal for them to go ahead and open those windows. I'll show you how the operable windows work, and then we'll talk a little bit about our indoor air quality strategy. This is one of our operable windows. You can see if you turn the handle one direction, it will go ahead and open the window all the way up so we can get that natural breeze coming through. We are on a major road, so sometimes we do get that traffic noise coming in through the window, and it might be a little distracting or a little loud. So we can go ahead and close the window, but then turn the handle 180 degrees and open it up through the top. So we still get that natural ventilation coming in through the vent at the top, but we don't necessarily get all the traffic noise. When utilizing the operable windows, the occupants have to check the local weather station's outdoor air quality numbers. Indoor air quality is a big, important strategy that we try to implement within our building. But when you're on a major road and you have the windows open all the time, you're letting all that bad air into the office, and then you're closing it up and the occupants are breathing it in. So the occupants are required to check the outdoor air quality first before opening up those windows. Now I'm going to take you guys to look at one of our resiliency strategies, which is a battery backup system. So we'll go check out those batteries right now. This is our saltwater battery backup system. Because of the red list requirements for the Living Building Challenge, we opted to go with a saltwater battery system instead of a lithium ion type system. This system can run our emergency lighting and our refrigerator for a week. If we had a bigger system and we're able to allocate more square footage to this system, we could tie our server to it, things like that. Now I'm going to take you guys into our mechanical room to check out our composting toilet system, our gray water system, and our future rainwater to potable system. So this is our mechanical room. As you can see, we have composting toilet units on both sides. One side is for our women's restroom, one side is for the men's restroom. We have 8 bins total, and they actually use a vacuum flush toilet system in order to get the compost product into the bins, which I'll talk about in a minute. But basically how these bins work, they rotate, so one bin is open at a time. So when somebody flushes the toilet, the waste will fall into one bin, and then the bin will rotate and go to the next bin. That way the composting piles remain even. It takes us about 3 years to get enough composting end product to harvest all of that, and that's simply because our system is oversized for our building. We didn't know at the time that we did this project how many bins we were going to need, and ultimately we figured out that we don't need 8. But nonetheless, we have a lot of composting end product at the end of 3 years to harvest and donate. These bins have to go through a dry, wet process, just like a regular compost would. They have to be rotated, and I generally rotate those daily. We add wood chips to these bins, and then basically how our vacuum flush toilet incorporates with this is it uses very little amount of gray water in the toilet. That gray water mixes with the waste, but is moved using air, similar to a toilet that you would find on an airplane or a cruise ship. It uses that vacuum. It grinds up the waste into pieces, mixes it with that gray water, and then it falls into the bin, mixes with those wood chips, and then gives us this nice end product. I can show you some of the end product and what it looks like. So these are the wood chips that we mix with this. I get these for free from our local utility district when they harvest trees around the city. And then this is kind of what the end product looks like. It's just a very dry dirt type material. And this has actually been tested for us. And it's certified under EPA, which is a US standard, Class A. Meaning it can go on any public property if they wished to use it as a fertilizer. So it's actually pretty cool, and we donated our first batch of compost to a educational farm in our area. So the other thing that these composting units do is, because they're doing the decomposition process, it does squeeze out some liquid, which is called leachate. The leachate ends up in this tank, or black water if you're familiar with black water. It ends up in this tank, and basically what I do is I get a pump and a hose, and I make sure that our black water system is closed looped by pumping that black water into the top of the composting unit, and that gives that wet factor that the compost needs. So it's just a big loop and a cycle that keeps the black water out of the sewer system, as well as gives the compost the liquid nutrient that it needs. This, you can see the composters have these fans attached to the top of evaporate all the black water that ends up in these. So it'll basically just exhaust out through the top of our roof, and that's how we keep our black water level down, as well as the smell. So these composters don't smell because the fan is running consistently, so the occupants don't smell any of the composting product that's inside the bin. So this side of our mechanical room houses our gray water system. So what happens is all of the water from our kitchen sink, our dishwasher, our showers, and our hand sinks all flow into this underground tank right here. This has a pump inside of the tank, and when there's enough water that it touches the top of a float, the tank will push it up to this pre-treated tank up here above my head. This tank is gravity fed, so it will sit in that tank while the water waits to be filtered. It will go into this tank first, which is full of gravel. This particular filtration process is meant to mimic a river, so it's no chemicals. So it will go into the gravel filter first. It goes down through the tank and then up through the tank, and then it goes into this second filter, which is full of sand. So again, it's mimicking a river. It'll go down, all the way down through the sand, and then back up to the top of the sand. And then when it's filtered enough, it will go into this storage tank right here. Now, this storage tank looks pretty dark, but what that is a bacterial film that grows on the inside of the tank. The water is actually very clean inside, and it will sit in this tank until there's demand for the water. So when our living wall turns on or someone flushes the toilet and there's demand for the water, it will go into the pressure tank, and then it will go through 2 more filters in the filtration process. It goes through a carbon filter, and then it will go through a UV light as the last process of filtration, and then it will go out to the wall or it will go to the toilet. And that is the gray water filtration process. This system does have to be cleaned. We try to flush out our system at least twice a year. And sometimes the filtration process needs a little bit of help, so we'll just add a couple scoops of some organic microbes into the filters to help that filtration process go a little bit faster. It's really important that the little microbe ecosystem in these filters stays healthy in order to help that filtration process continue. On this side, you can see we have a couple more filters. This system is currently not connected. This is our future rainwater to potable system. Currently in the state of California, we are not allowed to run our rainwater to potable system. That's due to state regulations. They won't allow it currently, but we're working on that process and helping to move some legislation and get that process forward. Right now we're actually in the men's restroom. I wanted to show you all kind of what that toilet sounds like. This is the toilet. It's just a normal toilet, and then it has a release button here. So when you push that button, you can hear the vacuum working, and then basically it'll just fill back up with water. This is the other side of our open office area. You can see it's similar to the other side. What we have in our office, we have a couple of interesting things that I'd like to point out. You can see this gray soft tube going across the ceiling here. That is called a duct sock, and we utilize that to help ensure that the mechanical system is blowing air evenly across the entire space. So all it is a soft sock, essentially, that has perforated holes across, and it connects to a normal duct across our ventilation system, and it'll inflate when it's on and it'll deflate when it's off. And this helps keep the temperature consistent across the space. Another thing I would like to point out on this particular side of the office, is you can see we have some workstations that have missing pieces. That is because as part of the Living Building Challenge says that you must adhere to the red list when sourcing materials and bringing materials into your building. The red list is a list of chemical classes that are known to cause harm to human health. We salvaged these workstations from one of our previous locations, and we utilized them in this space specifically so we could keep the amount of materials that we were bringing into this space, consistent with that red list, and making sure that we're not bringing in new furniture that's going to be off-gassing and harming people. And that's part of the challenge for Living Building Challenge, is sourcing all of those materials. Behind me you can see our two 5,000-gallon rainwater cisterns. They fill up during the rainy season in Sacramento, which is generally from October to about April or May, and then we have no rain all summer. So we need this much rainwater to water all of our exterior urban agriculture, and we generally use almost all of it in that time frame. Our urban agriculture, which is lavenders, we have blueberries, we have strawberries, we have grasses that can be used as medicinal plants, we have bamboo. We generally grow a little garden seasonally, and we have passion fruit vines, kiwis, so all kinds of plants that grow on the exterior of our building. We also have a bunch of wildflowers that we've planted that help promote bee pollination. We have 305 PV panels that make up our roof and our canopy. We are able to produce 176% of our own energy. Most of our PV panels have optimizers on them, as well as with occupant behavior, we're able to adjust that and get the most energy that we can possible. Part of our system that we have incorporated as a strategy is by utilizing something called a vampire switch. So when our alarm system is activated, it will activate that vampire switch, and that vampire switch will kill all unnecessary plug loads that would otherwise be running during unoccupied hours, to kind of put that footprint a little bit down